Choosing the wrong database means a costly rewrite later. SQL or NoSQL? This decision comes up in every single system design interview. Let me give you the framework to always get it right. SQL versus NoSQL trade-offs. High-level design, day 6. Let us start with SQL databases. PostgreSQL, MySQL, and Oracle are the most popular. SQL databases use a structured schema. You define tables with columns and data types. Every row must conform to the schema. This gives you data integrity out of the box. The 4 key strengths of SQL. First, ACID transactions. Atomicity, consistency, isolation, durability. If you are transferring money between accounts, both the debit and credit either succeed together or fail together. No partial state. Second, structured schema. Tables, columns, types, constraints. The database enforces your data model. Bad data cannot sneak in. Third, joins and relations. Foreign keys connect tables. You can query across related data efficiently with joins. Normalize your data and avoid duplication. Fourth, strong consistency. Every read returns the latest write. No stale data. When a user updates their profile, the next read sees the update immediately. Now, NoSQL databases. MongoDB, Cassandra, and DynamoDB are the big 3. NoSQL databases break away from the rigid table structure. They offer 4 key advantages. First, flexible schema. Store JSON documents without a predefined structure. Different documents in the same collection can have different fields. This is great for rapid iteration when your data model is still evolving. Second, horizontal scaling. SQL databases typically scale vertically by getting a bigger server. NoSQL databases are designed to shard data across many machines. Cassandra can handle petabytes across thousands of nodes. Third, eventual consistency. In a distributed system, writes propagate to all replicas over time. Reads might temporarily return stale data, but the system gains massive availability and partition tolerance. Fourth, specialized models. NoSQL is not one thing. Document stores like MongoDB for flexible JSON. Key value stores like Redis for fast lookups. Column families like Cassandra for time series data. Graph databases like Neo4j for relationship-heavy data. Let me put them side by side. SQL strengths. Complex queries with joins across related data. ACID transactions for financial and critical systems. Data integrity enforced by constraints and foreign keys. A mature ecosystem with decades of tooling. Strong consistency where every read is the latest write. SQL is best for financial systems, user accounts and authentication, e-commerce orders, and any relational data model. NoSQL strengths. Horizontal scaling to handle petabytes of data. Flexible schema for rapid development cycles. High write throughput for event streams and logs. Low latency at massive scale. Geographic distribution across regions. NoSQL is best for real-time analytics, IoT sensor data, content management systems, and session stores or caching. In practice, most large production systems use both. SQL for transactional data like payments and user accounts. NoSQL for high throughput reads, and flexible documents like product catalogs and activity feeds. Let me break down the 4 types of NoSQL databases. First, document stores. MongoDB and CouchDB. They store data as JSON documents. Each document can have a different structure, best for content management, product catalogs, and user profiles. Think of it as a flexible filing cabinet where each folder can contain different types of papers. Second, key value stores. Redis and DynamoDB, the simplest model. You store and retrieve data by a unique key, lightning-fast lookups. Best for caching, session management, and leaderboards. Think of it as a dictionary or hash map at massive scale. Third, column family stores. Cassandra and HBase. Data is organized by columns rather than rows. Optimized for writing and reading large amounts of data in specific column patterns. Best for time series data, analytics, IoT sensor data, and event logging. Fourth, graph databases, Neo4j and Amazon Neptune. Data is stored as nodes and edges representing relationships. Traversing relationships is fast because they are first-class citizens. Best for social networks, recommendation engines, and fraud detection. Here is the decision framework I use in interviews. Step 1. What is your data model? If it is relational with users, orders, and joins, choose SQL. If it is nested documents like catalogs or CMS, choose a document database. If it is simple key lookups like cache or sessions, choose a key value store. If it is time series like logs or IoT, choose a column family. If it is relationship heavy like social networks, choose a graph database. Step 2. What are your consistency needs? If you need strong consistency for banking or inventory, choose SQL. If eventual consistency is acceptable for social feeds or analytics, NoSQL works. Step 3. What is your scale? If you can scale vertically with a single powerful server, SQL is simpler. If you need to scale horizontally across many commodity servers, NoSQL is designed for that. Step 4. How fast does your schema change? If it is stable and well-defined, SQL enforces it. If it is evolving rapidly with frequent iterations, a document database gives you flexibility. Never say NoSQL is better than SQL in an interview. Show that you understand the trade-offs and can pick the right tool. Common interview questions and answers. Design a payment system. Use SQL, specifically PostgreSQL. ACID transactions are non-negotiable for money. Every transfer must be atomic. Design a social media feed. Use NoSQL, specifically Cassandra. High write throughput for millions of posts. Fan out on write pattern. Eventual consistency is acceptable. Design a URL shortener. Use a key value store like DynamoDB. Simple get by short code, put with long URL. Millions of reads per second. Design a recommendation engine. Use a graph database like Neo4j for traversing user-product relationships, combined with SQL for user account data. The interview framework. First, identify data access patterns. How will the data be queried? Second, determine consistency requirements. Can you tolerate stale reads? Third, estimate scale in reads and writes per second. Fourth, consider schema flexibility needs. Fifth, pick a database category and name a specific database. Sixth, always justify with trade-offs. The winning answer always discusses trade-offs. Show awareness of the CAP theorem. In a distributed system, you can only guarantee 2 of consistency, availability, and partition tolerance. 5 things to remember. SQL gives you ACID transactions, joins, and strong consistency. Use it for transactional data like payments and user accounts. NoSQL gives you flexible schema, horizontal scaling, and high throughput. Use it for analytics, IoT, and content. Most production systems use both SQL and NoSQL together, each for what it does best. Always justify your database choice with trade-offs around consistency, scale, and data model. And in interviews, never say one is better than the other. Show that you understand when to use each and why.